Okay, so here we are at the back table now. Our harvested fat is in these syringes. We've passed them to the back and we've put them in this syringe stand, which has been devised by Tulip to keep the syringes in upright position. We're using a gravity decantation method today. You can use centrifugation if you wish. Normally if I do that, I'll use 1,000 Gs at 3 minutes for the syringe. You have to be very careful not to exceed the tolerance of the cells though, which usually is around 1,200 Gs. But today we're just using gravity, and so we position these syringes like this and let everything layer out. You can see that we're starting to get separation now. We're getting an infranatant at the bottom, which is our residual tumescent fluid, cellular debris, blood cells, blood, those kind of products. The middle layer is our fat. That's where our graftable fat is going to be. And then we're getting a supernatant layer at the top, which is mainly oil from ruptured adipocytes. And when it comes time for us to do our graft, we'll decant the infranatant and the supernatant and keep the fat graft, and that's what we will use for our transfer. Right now we're going to get rid of the infranatant part, and you can see I'm just gently depressing the plunger till we get all of that fluid out, and then let's get the first couple of drops of fat. Now we're starting to get into our fat, and that part we want to preserve. We just had here. So there we have decanted the infranatant from all of our syringes. That leaves us with the graftable fat layer and the supernatant oil, which is a thinner layer in these grafts. And a lot of that has to do with the technology that we use. The Tulip so-called self-friendly, their proprietary self-friendly cannulae have a coating on the outside and on the inside, which really minimizes the disruption of the adipocyte. So you truly should not have a big supernatant layer if you get a good harvest. Okay, so the next thing we're going to do is start so-called processing the fat, micronizing, emulsifying. These are all terms that mean the same thing. And basically the way we do that is through a series of these little transfers, and I'm going to arrange them here by size so that you can see. So it's a series of smaller and smaller transfers that have a filter inside. It starts from 2.4 millimeters, drops down to 1.4 millimeters, which is blue. These are all color-coded too. Purple is 2.4, blue is 1.4, green is 1.2 millimeters. And then finally our Nano Fat Transfer, which essentially it creates the nano fat, gets rid of all the adipocytes, the mature adipocytes, and leaves behind the small tissue stromal vascular fraction particles. The purpose of that being that we can inject those small particles through a 27 or even a 30 gauge needle to get it to places where we want to go with very superficial injections, and we're looking mainly for regenerative effects there, not so much volume like a structural fat graft. So things like scars or under the eyelids where the tissues are very thin, those might be indications for nanofat. So we're going to be doing nanofat today on a couple of scars on this young lady. So we will be going through the whole procedure, the whole process. So let's go ahead and get started. First with the 2.4 cc emulsification. And we're going to draw up from our graft. I'm going to take one of these here. So the key is we're going to pass these 30 times. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sometimes we get an obstruction, and that's really the whole purpose of this. 19, 20, 21, 22, 3, 4, 25, 26, 27, 28, 29, 30. And I may go a couple more for good measure just to help break this up as we get obstructions. Now we're going to drop down to the 1.4, 30 passes. So it's 30 passes with each of these transfers. And again, first time sometimes there's a little bit, there's some resistance. And if you do get a fibrous component, there we go, that's been, some of this has to do with the harvest site. We harvested this fat from the flanks, and the flanks are notoriously more fibrous. So, and this looks frustrating, but it's actually the purpose of this. You get rid of all of that debris. And you can see the characteristic of the fat is changing too. It's becoming a little creamier, a little whiter. We're actually disrupting mature adipocytes. That's part of the plan here. We don't really want to transfer mature adipocytes. That's not the thing that lives in these fat grafts. We've discovered that. Now we're going to switch down to 1.2. Okay, so that is 30 passes all the way down to the 1.2 millimeter transfer. This is what we refer to as microfat. So there are different terms that are sort of emerging. I tend to favor macrofat or structural fat for this that hasn't had any processing, or maybe down to the 2.4 millimeter. Then down to the 1.2 millimeter, we'll call this microfat. Again, the only significance of that being that it's small enough that we can get this through a 25 gauge cannula or a 27 gauge needle, a lot of times with microfat. So we've transferred to a 1 cc syringe so that the pressure is a little bit greater through the syringe, and we're going to try to get this microfat. There you go. You can see microfat can be injected through a 27 gauge needle actually. Half-inch needle works a little bit better than a 1.5 inch needle just because of the drag. Here we are. We're going to do our final processing step. This is the Nano Fat Transfer. We've got our microfat, which has been emulsified down to the 1.2 millimeter transfer. We're going to transfer it into a 1 cc syringe. This is best done on a flat surface and with continuous pressure. And I like to get the air out first, because there's always some air in the chamber. So I get that out first, and then when I've got actual fat coming through, then I put my syringe back on. And I think that a slower, steady pressure on this will give you a higher quality nanofat. I think if you press too hard, too fast, you tend to force through larger particles that you don't really want, and it tends to occlude your needle. So this is nanofat here. Now, certainly I'm going to be able to get this through the 27 gauge half-inch needle because we got our microfat through that. So you can see that. Let me see a 30 gauge half-inch. Do you have a 30 gauge half-inch? So this is a 30 gauge half-inch needle. And again, you can see very easily, no obstruction. And this is great for injecting intradermally. So for scars, for under the eyelids, to address those very difficult to address dark circles and thinning of the tissue. The nanofat through a 30 gauge needle is wonderful. I've really had gratifying results with that. So that's, in a nutshell, the processing technique, going all the way from structural fat, which is really what's harvested from the patient directly after decantation of the infernatant, down through microfat to the 1.2 millimeter level, and then the nanofat.